relatively clear day and seen what looked like a halo surrounding the sun. You may have wondered why that is, and some of you may have even heard the legend that this could even offer somewhat of a prediction of weather to come. Many people say when you see a halo in the sky, it tells you that snow is on the way or that rain is on the way. We'll actually talk about that more when we talk about weather forecasting in a few months, but right now I'm going to talk about how halos form. So, halos are a little bit different than rainbows, even though they do involve sunlight refracting off of clouds. The difference, however, is that halos need very thin cirrus clouds, whereas rainbows need large raindrops. And these cirrus clouds are really high in the atmosphere, sometimes upwards of 30,000 feet in the atmosphere. When this happens, when we have these really high, thin clouds, they're made up of ice. They're made up of ice. And ice treats light differently than liquid water, what liquid water droplets treat sunlight. So ice treats sunlight differently. There are two types of halos. The first type is what's called a 22-degree halo, and this is a halo that forms at 22 degrees away from your line of sight. So if you were looking straight at the sun, which I recommend that you don't do, but if you were looking straight at the sun and you were to tilt your head 22 degrees in either direction, up, down, left, or right, that is where the halo would be present. The second type of halo is what's called a 46-degree halo. This is basically the same thing, but instead of looking at 22 degrees, you look at 46 degrees. So you tilt your head a little bit further in any direction. And that is where a 46-degree halo is. Now, these two halos form from different types of ice crystals. 22-degree halos form from very tiny ice crystals. 46-degree halos form from larger ice crystals. So here's a 22-degree halo, and let me use my little pointer here to kind of show how this works. So here is the sun, and just look straight at the sun right now. Look at my red dot floating over the sun. Well, if you were to tilt your head so that you were going from the sun right here over to, sorry for the terrible drawing, over to the edge of the halo, you would have to tilt your head 22 degrees. And again, this is true for any direction. 22 degrees up, 22 degrees to the left, 22 degrees to the right, 22 degrees down, 22 degrees in any direction. And then a 46-degree halo would be one where you had to tilt your head 46 degrees. So here's how these halos form. These halos actually form via refraction. So if you remember when we talked about refraction, it's basically light changing its direction as it travels through different media. And media, again, are just things that light travels through. So air, light travels through air. Or water, light travels through water. And these different media have different densities. Well, ice has a different density than liquid water does. And so when light enters one of these ice crystals, sorry, this pointer sometimes misbehaves. Give me 1 second. Here we go. When light enters an ice crystal, it then bends at these two particular angles. It bends at either a 46-degree angle for larger ice crystals or a 22-degree angle for smaller ice crystals. But this is why we see these two halos. Now, going back to the whole idea that this could be used to predict future weather events, well, typically, really high, thin, layered cirrus clouds, like the type that produce these halos, usually represent the approaching of a warm front. And warm fronts end up being the leading edge of what's called a mid-latitude cyclone. And we'll talk about mid-latitude cyclones in a few months. We'll talk more about weather forecasting in a few months. But it's just these particular clouds typically preclude those kind of events. So that's why these are often used as predictors. Now, one interesting thing is this light doesn't just bend perfectly, but scattering can also happen. And this can create things such as an upper tangent arc or sundogs. And the way that a sundog forms is you have your sunlight and it hits an ice crystal, and that ice crystal, if it hits it at just the right angle and it hits it right at its flat surface, this ice crystal can behave just like a prism. So not only does it bend the whole beam of sunlight, but it refracts it into its individual colors. And hence you get what looks like these two bursts of light to your left and to your right of the sun. These actually look pretty cool. Here is an example of this. So you can see the halo, and you see these two bright areas, one on the left of the sun, one on the right of the sun. These are what sundogs are. The last cool thing I'll show you is if you've ever taken a look at the sky right after sunset, and you see these really beautiful pillars of sunlight that seem to be extending upward into the atmosphere, these are what are called sun pillars. And these happen when you have lots of ice crystals in the sky. So again, you have lots of high clouds, and sunlight just reflects off of them. And so you get this just beautiful reflection of sunlight. This is very similar to what happens when the sun has just set and you look up and the base of the clouds kind of have almost a reddish hue to them. We get those kind of sunsets here every so often. In fact, when I'm recording this lecture, just last week there was a really beautiful sunset like that. And you'll see more of them throughout the course of this class and the course of your lifetime. And there are different types of optical phenomenon that are related to cirrus clouds. And so we've talked about halos, both 22 and 46 degrees. We've talked about sundogs. I didn't get a whole lot into upper tangent arcs, so I don't expect you to know a lot about them. And then this idea of sun pillars, these usually happen either right after the sun has set, but sometimes you can also see them when the sun is high on, or when the sun is relatively high on the horizon. You can also see them extend downwards. The take-home message for this particular unit is I want you to understand the ideas of reflection, scattering, and refraction, and what they result in. So if you want to remember how rainbows form, they form from refraction of sunlight as soon as the sunlight enters that beam, and reflection as that light then bounces off the back of the water droplet. So when sunlight enters the water droplet, bounces off the back of it, and then heads out towards your eyes. And that's it for this particular unit.